Hello. Hello. Good evening, everyone. Hope you hear me. My name is Mohammad Amjad Pasha, and I am the technical specialist for mining solutions in EDS technologies based at Hyderabad office, India. Well, I welcome you to webinar session titled Latest Enhancement Features in GEOVIA Surpac. Before we get started, there is just a couple of things to mention. First thing, we will be muting the audience for the duration of presentation to reduce the background noise. And if you have any question at any point, please feel free to type into the chat box. Please feel free to send your questions or comments during webinar session. Time permitting, we will be addressing after the presentation has finished. Or if we don't get your questions due to time constraint, we will respond to you by email or phone call. Well, I would like to introduce you about EDS Technologies Private Limited. EDS Technologies has incorporated in 1994 and it is based in Bangalore, Karnataka. And EDS Technologies has 200 plus associates and it has 11 offices in India, in major cities of India like Bangalore, Mumbai, Hyderabad, Pune, etc. And we have 1,000 plus customers. And EDS is the largest PLM solutions provider in India for past 2 decades. It is the first company to start providing virtual reality solutions for real-time visual simulation applications. And it also has strategic alliances with world leaders including Dassault Systems, Autodesk, SAP, Resurgis, and other companies like VTMAC. And we have business solutions for various verticals like PLM, that is product lifecycle management, for design and simulation, for visual simulation, enterprise solutions, mining solutions, and engineering services. So these are the different business solutions we serve. And we also saw different industry verticals like automotive, electronics, aerospace, heavy equipment, labs, medical equipment, space, and mining, and etc. So we have all the strategic partners like Dassault Systems, Autodesk, SAP, Finite Solutions, Human Solutions, Resurgis, and other companies. So these are our strategic alliances. And coming to mining solutions, we serve for Dassault Systems GEOVIA. GEOVIA previously it was Gemcom software prior to its acquisition in 2012. And now it is a part of Dassault Systems, which is a 3D experience company. The main objective is to model and simulate our planet, improving predictability, efficiency, safety, and sustainability throughout the natural resources sector. And GEOVIA has different products like Surpac. Surpac is the world's most popular geology and mine planning software used for metal, base metal, and other non-stratified deposits. And the other product is Minex. Minex is also a mine planning software for only coal and other stratified deposits like your bauxite, phosphate, limestone, etc. And Vittel is the world's most trusted strategic mine planning software used to determine and optimize the economics of open pit mining projects. And MineShed is the most innovative scheduling software used to schedule your open cast and underground mines for a short-term or long-term scheduling process. And the Hub is software which provides secure remote collaboration. With that, you can organize, centralize, and enable the reliable sharing of exploration planning and production data over the low bandwidth connections also. And inside it is a software which uses to collects your progress of production activities against the plan. And it also address and understand the cause of variance, enabling optimized production and rapid return on investment. Well, this is a press release. In this press release, Dassault Systems extend its relationship with EDS technologies to include GEOVIA mining applications also. So we serve for Dassault Systems, and we are the leading Dassault Systems value solutions partner in India since 1998. And coming to our main agenda, we will have an overview of the new features introduced and other enhancements done in GEOVIA Surpac. Within this, it will cover demonstration of new resource estimation features, block model estimation and enhancements, and we'll follow this by block model converter, wavelengths, DraftSight, mesh tools, and other enhancements or fixes, and we'll conclude with question and answer sessions. Well, to increase the confidence within your estimation process through inverse distance or ordinary digging, there are two new fields such as Venn field and descriptive field are introduced, and you can include composite length for the estimation with smaller samples also. You can estimate the block model of narrow vein deposits by weighting each composite by its length. The number of drill holes that are used in estimation can now be stored, and it also enables you to store the true distances to the nearest sample and the average true distance to samples from the block model simplified for each estimated block. And it also allows the definition of your number of isotopic search distance for specified grade ranges. So with this, you can restrict the samples that is sensitive to the magnitude of the sample grade during estimation process. It will better estimate deposits with multiple population. So we can see the demonstration how it will use to search for different grade ranges. Let's go to the demonstration. Well, this is the Surpac window, and here this is my composite file for which I will be doing grade estimation. Okay. And here you can string one, that is white string. These are the regularly sized user-defined size composites, and string 2 are irregularly sized composites. These irregularly sized composites are almost smaller than the regular sized composite, that is defined composite length. These are generally called as the remnants of the ends of the composite interval. Okay, and this is my ore body, which I will be doing estimation. Okay, and coming to block model, this is my block model. Sorry, I will be opening again. Okay. This is my block model, and this is my constraint to constrain the block model within my domain. So coming to grade estimation with inverse distance, I will select block model estimation and inverse distance. Okay. Here I will select my string file, that is composite string file, and I will select string range as 1, 2, where I told you that string 1 are the regularly sized, or you can say user defined sized composites, and string to a irregularly sized composites. That is remnants of the end of the composites interval. And using the weight by a field option, we can weight all the composites by the length. When you create a composite file, in the string file, you can see one string, that is length of the composite is stored in that. So you can use that composite length here. So it allows you to correctly include them in our estimation. I'm selecting the composite and the description field, that is D7. And I'm going to set attribute to field, that is FE. I'm doing a grade estimation. And here you can see previously there was only anisotropic distance to native sample and average anisotropic distance to samples will be stored. And now these four new fields are added to true distance to the sample, average true distance to samples, number of samples, and number of drill holes. So the purpose of this derived information is to serve as an aid in the classification later on with these true distance, nearest sample, and average true distance. So you can use this information for classification in resource. So I'm selecting, giving a name, anisotropic distance, true distance, and average anisotropic distance, average true distance. Number of samples, you can include number of samples used during the estimation, and number of drill holes also. I'm applying this data source specifications form. And, coming to such parameters form, you can see one grade dependent tab is also added. Earlier it was one tab, that is standard tab. Now there is a grade dependent tab. If I choose to enable this option, it allows me to enter the anisotropic search distance for specified grade ranges. Here I will give default select from 45 to 55. I'm giving search distance as 50, and from 55 to 65 the distance will be 40, and from 55 to 68 the search distance will be 30. So with this you can configure your estimation. You can adjust search radius by grade cutoff ranges. And coming to a standard form, here you can give your maximum search radius, that is default search radius, giving us 100. Maximum vertical search radius. So you can see here the constraint by drill hole. So this option enables you to decluster the data and allows to limit how many samples to be used in one drill hole. This is used for declustering of your sample data. And here you can select maximum number of samples per drill hole. So I'm not enabling here. And next move on to ellipsoid size, shape, and orientation. Here I can enter bearing, plunge, and dip. And I can also enter major or anisotropy ratios for major to semi-major and major to minor. However, instead of using a single bearing, plunge, and dip values for the entire estimation, we can actually store in the block model the bearing, plunge, and dip on a block by block basis. This will vary the orientation of the ellipsoid and on the values in the block. This is called dynamic anisotropy. By selecting the attribute, you can select the attribute here instead of giving bearing length and width, common for all the blocks. I'm giving 0, 0, 0 and apply. So coming to inverse distance parameters, I'm selecting my power and discretization points, and I will choose to constrain the interpolation. And here you can see the report file name. The report file name by default will be your block model file name with your ID. And I'm selecting format as Notepad, hitting the apply button. Yes. And here we'll select my constraint that I have created. Add the constraint and apply. Okay. And these inverse distance parameters form will come, which we have entered. So from 45 to 55, I had given search distance as 50, 55 to 65, 40, and above 65 will be 30. So I just want to talk about block model processing. Coming to our presentation. Block model processing. Most of the Surpac functionalities are multi-threaded. Multi-threaded means when you try to perform the estimation, it actually uses all of the cores or processors available on your machine. This greatly speeds up the processing, and Surpac has been enhanced to use multiple cores when processing your Surpac block models, and it dramatically reducing your processing time. This majority of the block modeling functions includes this enhancement with performance improved for your estimation process, like inverse distance, ordinary kriging, simple kriging, or nearest neighbor method. Or for any estimation through partial percentages, and to perform any block maths. I can see that one of the person has a question. Yes, Rajkumar. Hello. Okay, coming to our presentation, these block model estimation enhancements is majority covered for estimation process, partial percentages, block maths, and for any block model reporting and all constraining operations. Coming to the search EDS, Mr. Rajkumar has a question regarding that. Here we can constrain. We can use the weight by description field to include your sample length. Hitting apply button. Here grade dependent. With this grade dependent, you can actually give the search radius for different grade ranges, for different grade cutoff ranges. So, here you can include up to 6 rows, that is up to 6 grade ranges you can use. So if you have any more questions, I will answer you after the presentation. And coming to our presentation. Next will be block model converter. Well, block model converter is a utility for processing block model data used in mining applications. Block model converter supports a variety of block model files for both input and output. You can use block model converter to convert block model data from one format to another format. You can also perform reblocking to modify block sizes and attributes of your block model for the conversion process, or you can modify or constrain data in an existing block model. Coming to the demonstration, this block model converter you can open from here, go to block model and convert and reblock. When you select convert and reblock, block model converter will open in the other window. Here you can open the block model, and here you can see this is the block model name, stored block count and user block count. So the difference between stored block count and user block count is the number of blocks based on the user block size which we give, and the stored block count is based on the physical size of the block model. The stored block count was uses super block values for a block model when all of its immediate neighbor have exactly the same value for all attributes in the model. So these are my stored block count and user block count. This is the difference, and this is my rotation point, and these are the block size for this block model. You can see block model attributes. These are the attributes, and here in the reblocking dimensions, you can enter your reblocking dimensions. That is, source block count is 29, 52, 23, and you can change the target block count by varying your target parent block size. And reblocking attributes, here you can select which of the attributes to be added in the reblocking process. If you want to add all the attributes, you can add all the attributes. And after that, you can select the reblock, and you can save it as various formats, that is .mdl Surpac block model, or in data mine block model also, free block model. You can even save it as in .csv format. And coming to the presentation, the block model converter allows you to reblock block models from other mine planning softwares like DataMine and Vulkan. So after importing your block model from other mine planning softwares, the new file will be created, that is with extension .fbm, means free block model. Now it allows you to correctly handle attribute names which has more than 8 characters, the calculated attributes, integer attribute types, and the rotation of your block model. And coming to viewing planes, the viewing planes can be used for a number of tasks. Geologists use planes to view vertical cross sections of drill hole and surface topography, while engineers use planes to view horizontal sections of a block model while creating a pit design. Surveyors use planes to create cross sections of areas which have been mined to display. And you can use viewing planes to examine sections of data in graphics. These planes can be saved as a string file. You can save the section file as a string, and you can view different planes in different viewports. Here I will show you the short demonstration of planes. I'm exiting this. So here in the when you open the Surpac window, here in the right side you can see a window, planes. So in the planes there are multiple options. Here in the fourth icon, this is for your quick planes. So when you select the quick planes, you can select your orientation. So before that, I will open my files. So this is my whole body with drill holes. So I will show you the planes applying on this. Coming to planes, here you can select your orientation. Like I'm selecting northing. You can give your start and an interval. By default, it will select start and selecting the extent of your data in the layer, and then selecting interval as 100. And there is an option here, snap to 2D plane view. When you select snap to 2D plane view, you cannot rotate in 3D. You just able to view in 2D only. When you unselect the option, you can rotate the data in 3D. And here you can save these quick planes in a file, giving a name. Just apply the button. Here you can see these are the sections. So one by one, I'll be showing you. So this is the top view. And this is your section view. So as I told you that you can view different sections in different viewports. So I was splitting this viewport into 2 viewports. Okay. In one viewport, I have the section of -400, and in this viewport, I can able to see -300 section also. And you can see different orientations in different viewports. So with this, you can able to see your sections in different viewports. You can again split this into horizontal also. You can here display grid also. You can also display the dynamic 2D grid to view your section data. So this is about viewing planes of your drill data on solid file. I will show you the fit planes of a block model. So this is my block model. Well, earlier we have estimated the grade estimation. We have grade estimation through inverse distance. There we have added some new features like true distance and average true distance number of samples. So you can able to see here from block model attributes, view attributes from one block. Select any block. Here you can see anisotropic distance, average anisotropic distance. This is my average true distance. These are the number of drill holes used for estimation, number of samples. To destination with my variable FE. So these are the different information stored in the block model as an attribute. So coming to quick planes, I'll be showing the quick planes for you. Selecting orientation or elevation. The viewing of block model in quick planes is used for pit design generally. So you can able to display the attributes, model attributes data in section itself by selecting this icon, that is display attributes and sections. Here I am selecting attribute FE. You can select your position also, and size, text size, and your units. And the font size also you can change. So I'm applying. Here you can see block model attribute values can also be seen in sections like this. Different sections you can able to see your block model attribute values. These will be most helpful during your pit design operation. And now I will show you how a section file can be saved as a string file. For that, I will bring bit designs. So these are the bit designs for 50th and 10th year. I will be taking a section using quick links. Previously, we have seen orientation in northing and elevation. Now I will going to use oblique orientation. Apply. So I'm taking this orientation. So, lower section view, you've been able to see. These are my surfaces. You've been able to see it as a string file by writing your triangles or polylines. In this way, your section file will be seen. You can save the section file from planes, save section to string file. From here, you can save your section to a string file. Just select it, give a string name, apply, with the caption. Here you can see the section which you have used. Now, save as section file. So in this way, these quick planes are useful. Coming back to our presentation, you can view your different planes in different viewports. Coming to DraftSight. Well, DraftSight is a Dassault Systems product, and it is a 2D design package with a wide range of plotting markup tools, a layer manager, and the ability to send plots to .dxf, .dwg, and .pdf file formats. Well, DraftSight is another example of the advanced technology and innovation being brought to the mining industry by Dassault Systems. And, whenever you are creating a plot file in Surpac, and it directly opens in DraftSight, as the DraftSight is now integrated with Surpac. So there is no need to use other CAD softwares because DraftSight is directly integrated in Surpac, and you can able to view your plot file directly into the DraftSight. There you can edit or modify your plot file. So I will be taking one of the example. This is my plot file. You open the plot file, it directly opens in the DraftSight window. So this is my plot file. In DraftSight, you can add any text, or you can modify any line or polyline. I'll show you how to add text here. Next, this data, and changing the size of font. This way, you can give a name, or you can draw any shape. Like square, if you draw any square here, you can hatch the data also. You can able to hatch the plot file. So for hatching, just select the data, type the hatch in the command bar. The bottom of window is your command. Type hatch, and here you can select your entities. So I'm selecting this entity. Enter. You can select your different patterns. Here, these are the different hatch patterns. You can select your scaling also. for hatching, and the angle. This way you can hatch by varying the scale, hatch scale. You're able to see hatch in different forms. This way you can include hatch also. You can include name or any shape, or if you want to include any building here, you can just draw your polyline. Go to draw polyline and draw with the dimensions like 20 by 20. I'm selecting the polyline. You can close this. Like this, you can add any shape or anything. You can draw in a freehand style. And you can copy or move these. Right. I'll be copying this. You can copy multiple of things. At a whole, you can move also. It's a very simple process here. Editing any of these. As a whole, you can make them as block. These are the different individual entities. You can make a block by selecting all of this. Just type block. Give the name. This name will be saved as a layer in the 2D package. Block. Now you can see when I am selecting a single box, single square, the whole blocks are selected. And you can explore them also. You can make individual blocks. The explode option. You can see the explode. You can include your dimensions also. For calculating any distance between them. You can add dimensions in aligned manner. Like this way. You can add dimensions here. Or if you want to draw any arrow, that is here it is called as leader. For this, style LE, and you can add an arrow. You can type a name here, and you can add an arrow here. If you want it, you can explode it. You can increase thickness from here. In the left side, you can see different properties of it. Here you can change your line or arrow thickness by varying the thickness here. You can able to see. Like this. You can do various 2D package operations here. It's a very easy software, very easy to learn. Here you can even edit your title box also. Right. Click it, and instead of GEOVIA, you can type your company name. And you can save it as your drawing file. You can see these are different formats. You can save it. It will be 2013, 2010, 2007, 2009, 4, 6. So these are the different formats you can save from DraftSight. It allows you to save one format to another format. So this is about DraftSight. And coming to our presentation, coming to mesh tools. In mesh tools, there are 4 different tools are there. One of the tools is linear clearance analysis. This linear clearance analysis is used to determine the distance between the solids or surfaces and other solids or surfaces and drill holes or segments. If intersected, the intersection is displayed in the graphics in the color you mentioned, and if the solids or surfaces do not intersect with each other, the line of closest approach and the minimum distance in graphics is displayed. I will show you a simple demonstration of linear clearance analysis. For this, I'm going to open topography and overbody. So you can see this is my topography and overbody. I will calculate linear clearance analysis here. So for this, you can select the function through surfaces mesh tools or from solids mesh tools. Use linear clearance analysis. Here by default, it will show you the layers whichever you have opened in the graphics. Here you can see my top and lower body layers are there, and these objects are selected. And here you can give maximum clearance to show. You can limit the data here. You can select the color for intersection. You can select the different color for clearance color and the line pattern, marker style. If you want to save the data, so if you want to save the data which is displayed in the graphics, you can give file name, then giving file name and format is the notepad. Use different format. Here you can see. You can see these two objects are intersected, so it is showing in red color as we have given the red color. The line is showing, the dotted line, showing the clearance distance. So this is the line of closest approach and the minimum distance. And here then the report form, you can able to see the clearance distance for each object, the bearing and dip for those objects also, and your x from and y from and z from to x, y, z. So in this way you can do your clearance analysis and generate a clearance analysis report. And the presentation. So in this way you can calculate your shortest distance between any solid and a surface, or between any holes and a surface, or between drill holes and a solid, or between any two solids. Deviation analysis. This is also one of the tools of mesh tools. Deviation analysis, generally known as your boundary analysis or mineralized boundary analysis. This function can be used to analyze the difference between two solids and surfaces. It is used to determine your safety boundaries when an open pit mine approaches and existing underground workings. This method can also be used to compare a planned and mined underground pipes to determine where insufficient material has been excavated or where more material has been removed than planned. With the help of deviation analysis, you can able to know all these data. Coming to next mesh tool, that is expanding or contracting solids. With this function, you can expand or contract, or both. You can expand or contract a surface by a set distance. So to create a valid solid by expanding both sides of a surface and closing it, this function can be used. I'm going to show a short demonstration of that. I'm going to select my topo. This is my topo. I'm going to expand topo. This select solids, mesh tools, and expand or contract. I'm selecting my object range by select button. It allows you to select your object. Here you can view your expansion distance 50, and you can set your precision also. You can set your precisions. You can either override the existing file or you can create a new layer. And the simplify results. Simplify results means if you select the map side, it will reduce the triangles, number of triangles in the file. When you go to the minimum side, it will increase the number of triangles, but it will not compromise on the geometry. line, you can see this is expanded. You can either select to this solid also. And I'm selecting this file, save, success, mesh tools, selecting an object and expansion distance. You can select here. Earlier I had done only a single side of surface that is expanded. When you give the positive data, it will expand. When you give the negative data, it will contract. I'm selecting now. I'm selecting both sides and as solid also. I'm overwriting this file. Here you can see the topo is expanded and became solid also. So in this way, you can expand a contracted surface and make as a solid. And coming to the presentation, so our next mesh tool is Simplify Solids. Simplify Solids, it is used to reduce the number of points and triangles in a solid with a minimal effect on overall shape, area, and volume. It significantly reduces the processing time when it is used in other Surpac functions. So by simplifying, you can reduce your processing time also. So I will show you the demonstration of this. Let's say this is my solid. If you have any complex solid, you can simplify it. So for simplification, go to Solids, Mesh Tools, and Simplify. And you can select Object, or you can select if it has different objects. Then you can select Object Range also. Selecting one object only. And here you can say Simplify Minimum and Maximum. So if I am selecting Maximum, means if I am going to, by displaying triangles, it will let you know. So these are the number of triangles present. Okay. And now I'm selecting Simplify. See, when I'm selecting maximum simplification, and you can see the preview also. Hit the preview button. It will show you the volume change, triangles change, and surface area change. If you are trying to reduce the number of triangles, then these will be the changes in volume, triangles, and surface area. On minimum side, you can see number of triangles are increased, and there is a change in volume also. So with this, you can simplify your solid or any object, and you can overwrite this object, or you can save it as creating a new layer. So these are about mesh tools. So we have covered block model estimation enhancements, quick planes, block model converter, and mesh tools. And coming to other enhancements, when you are using your variogram modeling and indicator variogram modeling, you can now use a rectangular search area that is shaped like a pyramid. Earlier, you used to do the variogram modeling with the search type with cone only. Now, a pyramid shaped search area can also be used during your variogram modeling function. So, in cone, the tolerance in cone can be limited in length depending on the spread limit setting that you enter, and you can extend a cylinder from the flat end of the cone for a specified maximum distance. Here you can see spread. Spread means your angular tolerance in angle, and this is your spread limit, and this is a search angle. It is search line, sorry. And the other option you can choose is pyramid. The area that variogram uses for the search is in the shape of a pyramid, and the pyramid can be limited in length depending on the horizontal spread limit and the vertical spread limit. Setting that You enter and you can extend a rectangular prism from the base of the pyramid for a specified maximum distance. Pyramid is useful if you need to increase the height or width of the search area, rather than having a search area that extends equally in all directions. So this is one more enhancement in geostatistics point of view. The other enhancements are, and now you can see your navigator shortcut menu is reduced. It is reduced by converting the following menu commands, that is cut, copy, paste, rename, delete, and properties. And the tracking mode is also introduced to create a point at a precise angle or any distance from another point or active plane. So you in the back window, this is the navigator menu sorted. Shortcuts are cut, copy, paste, rename, delete, and properties. So the length of the navigator menu is reduced. And coming to drafting mode, you are trying to digitize any point. Here you can see drafting. By selecting snap with a drafting ruler, you can actually draw or digitize a point based on angle. So this is similar to your any CAD software. Using then length is also increasing and angle is also changing. So this drafting tool is used for the point at a precise angle or at any distance from another point. And the other enhancements are the maximum length of attribute name in a block model file is now increased up to 128 characters. Earlier, it allows you to enter only 30 characters. Now you can enter up to 128 characters by creating any attribute in the block model. And the whole ID is now correctly recorded in the D1 field when you digitize in snap mode. So when you are getting a section from the database, and when you are when you are digitizing using a snap mode, earlier it was incorrectly recorded in the description field, the borehole ID. So now the borehole ID is recorded in the description field when you use a snap mode function during digitization. And other enhancements are third-party software upgrades are happened. It is the version of the Giant software products Surpac uses has been upgraded. And Surpac has been upgraded to use TCL version also. The new TCL version is introduced, that is 8.4.18. And here you can see the installation of Surpac 6.7 or 6.7.1 is not supported on Windows XP and Windows Vista. So if you try to attempt to install Surpac 6.7 or 6.7.1 on this operating system, a message appears to inform you that the operating system is not supported and the installation is cancelled. So please upgrade your operating software to at least minimum Windows 7. And GEOVIA has every answer and every solution for your questions from your data, theoretical database, resource estimation, or undergone design, or dump scheduling, dump design, fit design, blending process, or any bit optimization also. Thank you for listening. Please let me know any answers you have.